Welcome everyone to today's lesson where we will be covering binary shifting. This is sort of the third technique that we need to learn about binary calculations. So the first technique that we learned was binary conversion. So this was simply how do we convert a binary number into a denary? Well, we need to put its place values on the top here, and we just add all of the place values that have a 1 underneath it, and we get the number 5. So that was binary conversion. Binary addition, again, we took two binary numbers or three binary numbers for GCSE, and we simply said we have to add all of the numbers together. So 0 plus 0 would be 0, 1 plus 1 would be 2, and you would put a 0 underneath that and carry another 1. 1 plus 1 plus 0 would give us 2, so then you put another 0, carry the 1, and put a 1 right here. So this would give us the number 8 here, and so on and so forth. So this was binary addition. Now, binary shifting so binary shifting basically multiplies or divides a number. So if we look at the first target for this video, we're going to see how to shift a binary number, and then we'll look at the effects of shifting a binary number. So how does it change it? So the first one, if we were to write a very basic binary number like this, so we say 0, 0, 1, 0, and we shift this number once to the left, so shifting 1 to the left, like this, would mean that we take this 1, or we shift all of the numbers by one place in this direction. So we can put a 0 still here, we would put the 1, because the 1 would shift once this way, and that 0 would be shifted there. This 0 would be shifted to another position here, and then you would put an extra 0 at the end, like this. And you can even write it like this, really, put that 0 there, it doesn't really matter. But the point here is that we shifted all of these numbers one column to the left. So number 2 became number 4. The reason why I say that is if I just erase these arrows here to make it a bit more clearer to see, if we put the place values on the top, so we have 1, we have 2, 4, 8, and 16, we see that with this number, with this binary number on the top here, we were representing the number 2. By shifting it once to the left, we now represent the number 4. If we took the same binary number, so let's just write it simply like this, 1, 0, and we shifted 3 times to the left, then this one would be shifted 3 place values or 3 columns to the left. So we would have the 1 over here, then this 0 would be over here, then we would put 3 zeros at the back like this, and number 2 would be changed to number 16. So we have the number 2 being represented here and the number 16 represented here. Okay, now the same thing can happen in the other direction. So if we have, for example, the number 8, 1, 0, 0, 0 like this, and we shift this number 2 to the right, then we take the 1 and we put it 2 columns to the right, so we would put it here like this, and we put this 0 over here, like so. So again, now we have the number 8, which is being represented here, turning into the number 2. So shifting like this basically multiplies or divides these numbers. So now that you've learned how to shift binary numbers, actually let me just show you guys as well what happens if one of the ones falls off at the end. So for example, if you had let's say 1, 1, 1, 0 like this, and we shifted this number twice to the right, then that would mean that these two numbers would be completely lost, because shifting this twice, if we just put like an imaginary wall here, this number would be shifted past here, and so would this 0 as well. And this is absolutely fine. All you need to do is just not worry about these and just shift these two numbers to these position right here, to these positions right here. So it doesn't matter if some of the numbers fall off at the end, you just completely ignore them and you push everything else to the correct position. But when you're shifting to the left like this, the only thing you will put at the end is a 0. So for example, again, just if we shift number 2 to the left by 2 places, then we would have 1 0, which is these two numbers here, and then on the other place values we would put 2 more zeros. You wouldn't put ones there. There's no need to do that, so don't forget this if it comes up in the exam. Okay, now let's have a look. Let me just clear up some space here on the digital whiteboard. Let me just erase this as well. So we know now how to shift these numbers. Well, the effect of shifting is, as I said, shifting to the left means to multiply, and shifting to the right, so this one is left and this one is right, then shifting to the right means to divide. So we can see here, by shifting this number 2 once to the left, we are multiplying the number 2 by 2, and it's becoming number 4. If we shift the same number 2 down here, to the left by 3 places, we are multiplying it by 2, by 4, by 8. So let me repeat that again. If you are shifting a number once to the left, you are multiplying it by 2. If you are shifting to the left by 3 places, you are multiplying by 2, by 4, by 8. So you're not actually doing, 2 times 2, then times 4, then times 8. You're just multiplying it by 8, in fact, because it's 3 positions. But because it's 3 positions, you're multiplying by 8. Simple as that. So 2 becomes 16. If you are shifting by 5 positions, then you are multiplying by 32. Okay, so it's a very simple process. With practice, you will get it. Now the other one, shifting to the right, which is the divide here. If we take, for example, the number 8 again, like so, and we shift to the right by 2, then the same process applies. You are dividing by 2 by 4. So divide by 4. So 8 divided by 4 gives us the number 2, like this. Now you might be wondering, what if you get a number like the number 5 here, and we shift the number 5 to the right by 1 column? So let me just draw a line here so we can separate these numbers. So if we take the number 5 and we shift to the right by 1 column, then that means that we lose this value here completely, and we get the number 2. So we divided by 2. We divided 5 by 2, and in your mind, obviously, as you've been taught, 5 divided by 2 gives us 2.5. But because it does an integer divide, it completely throws the decimal point away and leaves us only with the integer value. So when you are dividing or shifting to the right, any value that goes past that invisible column at the end or invisible line at the end is completely disregarded, thrown away as garbage, and we are left only with the whole number. Okay, and you can practice this